This week on Today in Space, we're talking about lunar landers, we're talking about moon missions, and we're talking about multi-material 3D printing. We're going to talk about the Intuitive Machines Lunar Lander that's launching on a SpaceX Falcon 9. This is being recorded on Valentine's Day, and later tonight, around 1 o'clock a.m. Eastern Time, SpaceX should be launching the Nova-C lander for NASA for the Prime 1 mission and all the payloads on board. We're going to talk about that, and I'm going to talk more about my 3D printed Valentine mission patch for this Space Valentine's Day. Welcome to Today in Space. Let's get into it. All right, folks, thanks for joining us on Today in Space. Welcome. Before we get started, don't forget to follow us online on social media, Today in Space Pod on Instagram and Twitter or X, Today in Space on TikTok, and Today in Space Podcast on Facebook. You can always email us at todayinspacepodcast@gmail.com if you're interested. You want to talk about something on the podcast. We're about all things space here, so we welcome anything that you'd like us to talk about here on the podcast and any kind of questions you guys have if you guys want us to go deeper. And we also highly recommend our Spotify playlist, the Space Mix. It's free, it's online, it's a public playlist that we add songs that have everything and anything to do with space, but most importantly, it's a jam playlist. It's something you put on when you're stargazing, when you're waiting around for a rocket launch like we're doing tonight for the IM-1 mission, or if you're just trying to get pumped up, like I listen to that not only throughout the day, but definitely before this podcast to get into the zone. And it's a great playlist. So the Space Mix, go check that out on Spotify, is something that we're always adding more things. Email us at todayinspacepodcast@gmail.com with anything else that you think should be on that playlist. So let's jump into the podcast. So the Intuitive Machines IM-1 lunar lander is launching on a Falcon 9 from SpaceX. It's going to the moon to soft land and spend its 14-day life on the surface of the moon, delivering a whole bunch of payloads, some for NASA, some for commercial payloads. But one of the first things that I thought was really interesting after we learned about this mission, we, in our episode to start the new year, we did our Space in 24. We talked about the 24 things in space to look forward to. The Prime 1, IM-1 missions were on there. The Lunar Trailblazers mission is on there. And from a NASA perspective, what the Intuitive Machines lander is a cheap, or cheap is the wrong word, but it's a budget-friendly lander that's built for a very specific purpose to, within budget and to enable business from people who can't afford to spend what NASA spends on a lunar lander. It's bringing things to the surface of the moon. Now, we just saw, Astrobotics just tried to do it, and they didn't even make it to the moon's surface or be able to attempt the landing on the surface because they had an issue after launch on the way out there. We know that it's treacherous. We know that just because we've gone there before and we landed the first human beings on there and had an extensive Apollo program where we kept sending human beings to the surface of the moon to learn more, even though we did that, it doesn't mean that we're just going to be able to do that again. In recent years, the only organizations, countries to do so successfully, to soft land on the moon, have been India and China, and Japan recently with their SLIM lander, China with their rover on the opposite side of the moon, India with their Chandrayaan lander. It's not something that people are just going to be able to do. And so even this IM-1 mission is not guaranteed, but in the whole concept of this, NASA basically bought 3 landers. IM-1, this Nova-C lander, is called Odysseus, and basically it's offering, they didn't spend the high-end budget that you would expect from, say, if NASA was building a lander, right? It was built by Intuitive Machines for a very specific 14-day window. And they're only launching right here at the middle of February because by the time they get to the moon, that will be in the south pole of the moon where the sun will start, where that part of the moon will be in sunlight for those 14 days. Because the way that it's built, in order to cut budgets and be light enough to launch on a Falcon 9 to the moon, not something we see very often. The design of this mission was to take out some of the things that would make the lander robust even through the dark periods on the surface of the moon where there is no sunlight, which means that lander would have to endure extreme temperatures. There are payloads on this lander that are designed to last longer, but the lander itself is only designed to last 14 days, and I thought that was fascinating. And the reason that I thought it was fascinating is not so much that it's inexpensive. It's not so much that, and many of the things we talk about here on the podcast, making going to space cheaper and less expensive and more accessible is super important. What I love about this mission is that it involves so many different people from around the industry, commercial payloads, SpaceX, NASA. NASA themselves, they're sending lunar trailblazers that are satellites that are going to be orbiting the moon to gather information and scan through the atmosphere, the thin atmosphere that it does have, and the surface to track the water cycle. On IM-1, there's going to be the Trident and M-Solo instruments. Trident is the drill that's drilling down, pulling up regolith, which inside is going to have ice water. As that ice water reaches the surface, it's going to sublimate because the temperatures are going to be so extreme that it's going to go exactly from a solid to a gas with no liquid intermediary phase, which is crazy, and that's just the environment of the vacuum of space. The M-Solo is the mass spectrometer. It's going to take readings, so we're going to actually see what that drill is pulling up from the surface, learn way more about everything that is water on the moon and regolith and soil, which I'm sure Madison Fian from Space Copy is going to be excited about with their 3D printing that they're trying to do on the moon with Space Copy. This is huge for people who love infrastructure and something we all need to fall in love with in the space industry if we're going to be having humans out there in space long term. Let's take a break to talk about your brain. All right, and focus, because I think the world is so crazy right now. There's so much going on and so much that you feel that you've got to keep up with that even the act of just saying, nope, I'm going to sit down and focus, sometimes you're in a place where you just can't do that. Or you're not going to get the most, you're not going to optimize that situation. That's where I use Magic Mind. Magic Mind comes in for me as a huge daily regimen. I'm on the 30-day subscription. It's giving me less stress throughout the day, more energy, but while the name is Magic Mind, there's really nothing magic about it. It's a really interesting blend. It's this little elixir of vitamins and a mushroom blend, and it just has so many of these things that you miss out on when you're drinking coffee. For me, coffee's a huge caffeine is what helps the brain fire and the memory stick, and it really helps me get in the zone. When you're someone like me and you're working on something after work, or it's just been a long day or a long week, we've all got stuff going on, and you want to maximize the time you do have, Magic Mind is what does that for us. So if you go to magicmind.com, use code word Today in Space 20. You get 20% off, and that gets you off a single item, or you can add on and get up to 56% off your first subscription. So the real value is just jumping on that subscription, trying it out. It builds up every day that you use it, and you really get to like a nice zone of repeatable consistency in flow state, about like 3 or 4, at least that's what it was for me. So highly recommend giving it a shot, especially if you're spending, a ton of money on extra coffees after work. Get a subscription, drop 56% off, use code Today in Space 20, and you're spending half of what you're spending at least on a cup of coffee, and this is helping you supplement your coffee. And if you're really lucky, it will help remove caffeine altogether. But listen, we're not there yet. We're supplementing, okay? But it's a great tool to get your focus going, so I highly recommend it. magicmind.com/todayinspace. Use the code todayinspace20 for 20% off any item, and then up to 56% off your subscription. Check it out, magicmind.com. Productivity shot and a little magic elixir. And if you don't want just the magic, go to magicmind.com/science. Learn about what's in there. Check it out. Now back to the episode. We need stuff built. This is the new frontier. It's not like, it's like when Americans moved from the East to the West before there was anything out there, and settling the West. It was literally the Wild West, and it was lawless. Now we hope that the moon doesn't become lawless like some Futurama nightmare, but it's the reality. There is no internet, there is no GPS, there is no water. The resources need to be located and then extracted and processed. We need supplies regularly going to the moon. Like, there's so many things that we have built in our world here on Earth, especially people who are born today. There's so much built infrastructure, things around us, technology, Wi-Fi, like the fact that we can get a signal from almost anywhere we are, the fact that Starlink is going to make that even more accessible. We're living in this crazy age of technology, and we're going back to the Stone Ages here as far as what kind of technology we have in a place where we just haven't been in over 50 years. The Lunar Lander that is successful, that starts showing us what we can do, is going to help progress things so much further. When we talked about this, NASA has 2 more lunar landers for the Nova C that they've purchased that are planning to launch. The good thing is that because they can use a Falcon 9, that means there is a high probability that's going to happen quickly, and that, you know, the Falcon 9 is just a workhorse for the world right now of putting things into space. So, you know, if you can build something that can launch on that thing, even to the moon, it really is something special this time that we're living in. And something like a SpaceX Falcon 9, something that's a routinely flown trip to space, especially something that can go to the moon, like a Vulcan will be able to from the ULA, like New Glenn, which is coming out and being stacked down in Florida right now. It's so nice to see Blue Origin's work finally coming out from underneath the invisibility cloak of Jeff Bezos for the rest of us to see. That rocket looks amazing already. And there's so many things to be excited about here. But the more that we're able to go to the moon and have these rockets do this is great. And the fact that today a Falcon 9 can send a payload like this to the moon is insane. And we're super excited to see what happens. We wish everyone in this team luck as they go through this process of getting the vehicle ready. The first scrub on was actually this morning, 12:57. They had scrubbed the mission about an hour before that because the methane that was loading onto the lander itself was not the right temperature. So for anyone that's new, you know, they're loading. They want to get as much fuel as they can onto this rocket. That's just what makes things efficient. It's how you're going to actually be able to send something into space. These are just the basics of space and getting there. So in order to pack as much fuel as possible into this container, you need to cryogenically cool it down so that you can pack as many of these particles as you can throughout this process. When the temperature is too hot, you're not getting enough in there, and it also could mean other things. It could mean that there is a leak, that it's being exposed to the atmosphere around and warming up. There's a lot of different things that could mean. So they saved the rocket, they pulled everything off, and then they got it back on the pad, and hopefully tonight, and if not, they'll have other opportunities here. Limited window, though, right? Because you got to get there so that you can make the most of those 14 days of sunlight. Because again, that lander is only built to survive that. Although it'll be cool to see what survives once the next time there's sunlight that makes it over. Regardless, there's a lot of really cool things to see. Every new attempt we take here at the moon is progress, even if it is the astrobotics mission, especially the astrobotics mission, where we're learning that it's not easy. It's not just a given that we're going to get there. And that they still made the most of it, right? Like, even though it was a failure, in quotation marks, they still pulled as much as they could. They qualified stuff that went to space, which is one of the biggest reasons why you go to space in the first place. Most people don't plan to go to space just one time. They're planning to go multiple times. So when you're building a business around this and getting funding and finding a business case, you have to figure out a way to get out there and make a place for yourself in the space industry. A lot of that money and stuff is from contracts from NASA and things like that. So the more you can qualify your stuff going to space, the more likely it is that people that are going to space are going to take your equipment up there. So that's a lot of this game of going to space. Obviously, with the IM-1 Nova-C Lunar Lander, we want them to succeed and touch down and get intuitive machines as the first private company from the U.S. to land on the surface of the moon. It hasn't happened yet. NASA's done it, but that's the government. That was Apollo. That was the peak of government funding for space travel. We put the whole country behind that. That's a different scenario than we live in today. But we live in a really unique time where, even though you might not send the same, massive mission like Apollo, focused mission like Apollo to space, you are sending so many different attempts. And a company like SpaceX and Rocket Lab and all these other companies, Blue Origin, ULA, that are launching things into space, the more reps that we get, I think we'll be able to learn faster than we did back then. We're just going to get more attempts at it. And with the equipment being cheaper and the route to accessing space and the moon getting that kind of envelope expanding is huge for progress in space. And what this is all about, this Prime 1 mission from NASA and the IM-1 lander, this is all about building the Artemis generation. And that requires infrastructure. That requires us having all of the things set up so that we can send humans there and have redundancies. Make sure that they can communicate wherever they are, wherever the moon is in relation to us and the sun, and just making sure that we have as much as possible, just like we do with airplanes. You don't just get on an airplane that you don't know. Those pilots are in constant communication. They know where they are physically, altitude-wise, and direction. That's not a given in space. So that's why this is all so important. These are my thoughts about this IM-1 mission from Intuitive Machines, and we wish the whole team luck with getting there, successfully touching down, and allowing these payloads to do what they were designed to do. And in the process, we all learn. So that's my thoughts on the IM-1 mission. Now let's talk a little bit about this 3D printed mission patch, I guess you're going to call it. But yes, so in our lab, AG 3D printing, this is something I started a long time ago. If you're new, we have a 3D printing lab that we run. We make parts for people. We've got individuals that will reach out about, maybe projects they're working on. Maybe they want something 3D printed. We've got companies that have come to us if they've got a new idea, like SnapCollar, our friends who are solving the unkempt collar, the messy collar. We helped them with one of their original ideas of making the first prototype. And now they have a business. They're selling an actual product that they're mass manufacturing. And we're super proud of our friends at SnapCollar. But this is the type of thing that we do in our lab, we bring ideas into reality with 3D printing. And, we've 3D printed in one color a lot. Like here is our James Webb Space Telescope model, which will soon be available online if you guys are interested or want it. But we designed this to be specifically 3D printable. But you can get multicolor filament. That's how you would get a lot of color in a 3D printed part, but it's basically a monocolor 3D printer for the most part. You can do obviously multicolor things. You could paint parts, but 3D printing is not the best thing to just paint right off. Like you take that part off the printer and paint it. It's not going to go that well. You need a lot of sanding and sealing and coating, and there's a lot that goes into it. But with multicolor 3D printing, you can put the color exactly where you want it. And that's what we did here. We took basically we took inspiration from the actual patch for the IM mission. We've got the moon, we've got the name of the lander, the mission, NASA's here, the rocket, the Falcon 9, and then we even have the Odysseus lander right here as well in gold. But it was just having fun. This was, hey, the launch is going to be on Valentine's Day. Let me design something up real quick. I have the Prusa Mark III's, which is probably 2 or 3, maybe 4 versions old. Perfectly great machine. But we have the multi-material, which allows us to basically sort through 5 different filaments and use it wherever we want it. The software is nice and easy to use. You may have heard of a Bamboo Lab printer, an X1 Carbon. Another great machine that I know people who use. I don't have one myself. I have the Prusa and the multi-material, the MMU-3. We talked about this, and we'll get into this more later, but we brought this into reality within 24 hours, from design to color application to printing. And this is the kind of stuff that I am very excited is going to eventually go into living in space every day. When you're out in space, think about all the things that you buy on Amazon or wherever else it is that you buy things. I use Amazon because I think that's the most general example that everyone knows, right? There is no Amazon at this moment on the moon. And if you're not a machinist, if you don't know how to make something out there on the moon, it's going to be difficult. But even more than that, there isn't a lathe on the moon. There isn't a Bridgeport on the moon. There aren't injection molding machines on the moon. So we need to bring that stuff with us. The most, in my mind, the most compact, space payload friendly manufacturing equipment that you can bring wherever you are that's going to help you in so many different ways is a 3D printer. And so for us, I got into 3D printing because of this podcast. I saw that they were going to put a 3D printer on the space station that's made in space. That's the company that did the first 3D printer that was in space. The famous 3D printed wrench is from that printer. But even my first job in aerospace as an R&D engineer, we were looking at 3D printing as an option for getting this contract for helping make engines. And ever since then, it's completely intrigued me. And the more that I've done this podcast and the more that I've seen the industry use 3D printing, like obviously we talked about Madison Fian and Space Copy and what they're trying to do, build a rover that is a 3D printer and a whole additive manufacturing, colony building 3D printer that's going to be going to the moon. We've got that. We've got NASA is doing the long Mars missions in a 3D printed habitat. So it's not like 3D printing in space haven't been there, but we're living in this time where it's starting to become about what can you do in 3D printing. And as I talked about at the beginning of this year, we're starting to look for opportunities to get involved in analog astronaut missions and just be a part of this growing amount of people who are getting involved in helping us prepare for human life in space and what that's going to mean and how we would prepare for certain aspects of missions that we're going to have to do eventually when we go to other planets and make some kind of colony that people are going to live in. If you don't like the word colony, we can use home. That's good too. Shelter. But you're going to need to build a shelter. And as you live out there, your mission's going to change and things are going to break. So if you look at the Mars Research Desert Station, that's the Mars Society's analog astronaut, one of their recent missions, they actually had someone who was a robotics engineer, but was actually adapting the drones that they were flying outside to adapt for the mission. And they were 3D printing different parts to expand what was possible. And that's just a tiny fraction of what can be unlocked with a 3D printer in space. And with all of our experience here, I mean, we're killing it with the multicolor. We've got our James Webb Space Telescope coasters. This design is like a year old, but the color application is just beautiful. Thing of glory. This gold JWST logo on the outside of this stand, this wasn't possible for me before this upgrade. So we've been doing a lot of stuff here in the lab. We're getting excited about it and just learning all the different ways how a 3D printer can help solve a problem. For us, for me specifically, I am in this weird niche of people, even in the 3D printing industry, that has so many ideas that now the 3D printer allows me to get those ideas out, and to make things at a rapid pace, like iterative design on crack. Like, it is so much fun, and I'm really looking forward to talk more about this. We've got our lab that's finally getting to the place we're going to be able to record. You guys will get to see that and see more of my process in the lab as we 3D print things. But for now, some fun stuff like this Nova C Mission Patch Valentine. We wish the IM-1 team and NASA and SpaceX all the best on their launch. And this has been an episode of Today in Space. Thank you for joining us. A nice, quick 25-minute episode to get you guys going for the week. Spread love and spread science. Be well. And we'll see you on the next episode of Today in Space. Have a good one.